It's because the middle schoolers are watching us. They're watching a play virtually.
What was that from?
What's that?
What was it from?
Oh, it sounded like, I don't know. It's my phone now, but that wasn't that sound. Oh, no, no.
My phone just
What the heck?
not.
What in the heck? Where did it go?
I don't know. Mine said it was calling. Someone was calling me and it just like disappeared.
No.
An emergency alert.
Yeah, you get the emergency alert?
It says COVID is escalating.
Yeah, I just got it too.
While we're in public school.
Yeah,
I'm
so
guessing
everyone's
that's
phone
what
in the
it
building just went. Do you still have the alert on your phone?
Yeah.
Where do they go? Mine is gone now.
I think they go away.
Well, mine was up and
We're gonna be
I was
escalating.
about to explode.
See that website. But now, but see, like mine is gone now. And I can't bring it
Does
back.
this mean we're going online mostly?
No,
Is that for like everywhere, and everywhere that they send it to, or is that just?
I have no idea.
if you allow it in your settings, if you allow it. So I allow it, and then that dit noise is probably, I don't know, somewhere else. Oh well, we're still here, things haven't changed in the last 10 minutes, let's keep going. All right, so yes, you're right, Fiona, we put an X at the end, because we're saying whatever we're graphing is X. Okay, now, what else do we have to do? Let's get this done, put away your tools. It wasn't,
Find it alert, but I'll
Fix that.
it wasn't a tsunami warning, so we're all good.
This is true.
So what do we need to have on here to make it look good?
The number
A zero.
A 0 is always nice, isn't it? And a
7.
7 is nice, that's your end point. So how do we mark the line?
Open or close?
Ah, good, you remember that. Is it open or is it closed?
Open.
It's open, because 7 is not included, but where does X get put now? Where do we shade?
Down.
Is X bigger than 7 or is X smaller than 7?
Smaller.
7, so which direction?
Yeah.
Left? So is 0 a solution? Is 0 greater, is 7 less than 0?
Oh, no, alright, no, that brings go right.
So we're gonna shade to the right.
Go right.
Okay, so there we go, got it. We good? Is it complete? Awesome. All right, so now I'm gonna throw something else into the mix. I'm gonna say X is less than 12. Same thing, need a line, right?
Yep.
Gonna label it X, gonna put on a 0, gonna need a 12. I'm gonna say less than or equal to, just because.
Now you go that way.
So we go to where? Where do we start? What's our end point?
Well,
Closed, isn't it? Because 12 is equal to X as well. Then which way do we shade?
to the back.
To the left. All right, we good?
Yeah.
All right. So now what I'm gonna do is this. These are called single inequalities.
Oh no, you're gonna have like 3, aren't you?
I think we did double inequalities. I know we did. I mean, they were in that lesson. It was in chapter 2. So if I put these together, and I say that 7 is less than X, and X is less than or equal to 12, that gets written like that. And then what we gotta do is we've gotta have both of our endpoints, which are 7 and 12. We still label this thing X, but now we have to look at the overlap of these two. So things are gonna only go from 7 to 12. And it's still gonna be open at 7, and it's gonna be closed at 12. And X is gonna be in between these two. That's a double inequality, or a compound inequality. And what this is, so this is where it gets kind of weird. What this is this is the intersection of these two things. When you think about an intersection of streets, the intersection of 2nd and Main. Is that the bank? Is that where the bank, is that 2nd Street? I get the numbers all
The
mixed
next
up.
one over is 30.
Okay, next one. That's a pretty sharp way they do that, huh? Yeah. So second and Main, the intersection is that area out in the middle where both of the roads exist. That's the intersection. If you go up to the Bamboo Room, you're not on Second and Main anymore. You're up from Second and Main. You're not at the intersection. So, in this case here, this is an intersection where we use this symbol. So this is the intersection of these two sets of numbers. So let's say that this answer here, we call that set. It's a set of answers called A. There they are. We shaded them red. And then we said down here, well, that this is going to be called set B. It's a set of answers that we shaded here. If we look at the intersection of A and B, that's this overlap. It's a technical thing. You know, just know when you see that symbol, it's things that are in common in both of these groups here. And so in this case here, we're looking at the numbers that are found in this and in this. It's in both of them. And that's where the word and comes into play here. So the numbers that are involved in this inequality and that inequality together is the overlap. That's the intersection. You're acting like a middle schooler right now. Don't do that. Okay? Bad regression. So let's mix it up. Let's change something. I'm not big on this one. Let's look at this. Let's look at that. What we're doing is we're changing the direction of the inequalities. So if I put those two together, then 7 is greater than x, which is greater than or equal to 12. Note the direction of the inequalities. When they're pointing to the right, and the numbers are in order from smaller to greater, it's going to graph differently. Almost all the time, you guys, you're going to see work like this here. But I think what we're doing is we're just pointing out that it can be written differently. Sometimes it can happen like this here. And if we were to graph this, we need 0, we need 7, and we need 12. So let's graph this. X has to be smaller than 7. So which direction do we go from where?
Down the left.
From 7. And it's open, isn't it?
Yeah.
Now, x has to be greater than or equal to 12. So we start, yeah, right? So it's here on over. So now what we're doing is we're leaving x out. We're saying that the numbers have to be smaller than 7 or bigger than 12. Smaller than 7 or bigger than 12. So this is an or situation. It's one or the other, not both together. This is that the numbers are bigger than 7 and they're less than 12, so you have an intersection. This can be confusing stuff, so I'm going to write it down. So the values for x are larger than 7, and I'm going to write capital and smaller than 12. Whereas this situation, the value for x is smaller than 7 or bigger than 12. The most important stuff, you guys, is can you graph them? It really is. That's what it is. Do you know the difference between open and closed? Which you do, clearly. And, you know, can you come up with endpoints? Throw a 0 in if you can. That's the most important part of this. And then interpreting some of the word problems to understand them. You know, we don't have to go through writing out example number 2, but you should look at it, okay? Take a look at example number 2. That's on page 229. It talks about fish tank temperatures. So they got a picture of a neon tetra there, which is these little tropical fish. Maybe you've seen them in fish tanks. And this person is trying to figure out what temperature they should set their fish tank at, because you can't just let them be at room temperature, because these tropical fish die, and it stinks. So they say they bought some neon tetras, and they go to these 3 different sites, and one website says 72 to 88. Another website says 68 to 74. Third website says 73 to 81. So what they do is they graph the 3 sites. If you look at, they have closed intervals, 72 to 78, 68 to 74, and then 73 to 81. And what they do is they look for an overlap for all 3 conditions. And they come up with that narrow little band between 73 and 74 degrees. So all 3 websites agree that 73 to 74 degrees is the appropriate temperature. So if you want to be safe, you set your tank at 73 or 74. That's what that question is all about. It's looking at this idea of overlapping, which is exactly what I did with you here. So let us move on. I think example 3 is really one that we need to focus in on because it's a little different. And you seem to have an understanding of this stuff because you pulled it up. Pulled up your memory pretty quickly. But example number 3 is going to look a little different. They give us this inequality, compound inequality we need to solve and graph. And the big part of this is solving it. So you can see in the middle they don't have just the letter M. They say 5M plus 4. But when we're done, we've got to graph M, which means we have to solve this thing for M. So if you cover up one side of this, can you see the inverse operations that you have to use to get M all alone? What would be the steps you would take? Subtract 4 and then divide by 5. So you have to do that to the 8. You gotta subtract 4, and then you gotta divide by 5. Is that okay? Is that clear? So if you look at this side, how do you work that side? Subtract 4, divide by 5, same, right? So here's what we do. When we subtract 4, we subtract it from all 3 columns. Here that 0 cancels. 19 subtract 4. Negative 8 subtract 4. And you're left with 5M. Divide everything by 5. And then you have negative 12 fifths less than M less than 3. So now you have your endpoints. Notice they're pointing to the left, so that means you're going to shade in between. Remember, these are pointing to the left, we shaded in between. So all we do is, we got a negative 12 fifths, which is like a negative, what mixed number?
2 and 2 fifths.
2 and 2 fifths. And I am okay with you just doing something like this. You don't need to have the perfect tick marks and everything. However, And make sure that you graph it correctly. So open or closed on
Open.
both ends, right?
No, it top, it says.
Oh, this one was or equal to, wasn't it? My bad, I didn't carry that down. Okay, so that's closed. And we shade between. We shade between because M is bigger than this number and it's smaller than that number. So call it M. M's. So that little trick in how to solve those, that's really the big new, or the new thing here. That's about it. So you gotta be able to get going on your work with that.